Today's lesson's on logarithms. What is a logarithm? First of all, we need to figure out what that is. Logarithm is the inverse of exponentials. So remember that. Logarithm is the inverse of exponential functions. So if log base b of x equals y, if and only if b to the y power equals x. So let's remember that. And let's write each equation in exponential form. So first of all, let's look and see what b is. B, 2's in the spot of b, so b's 2. 8 is in the spot of x. And 3 is in the spot of y. So now let's go over to this equation. B to the y, what's b? 2. What's y? 3. Equals, what's x? 8. Now we can check this. Go to your calculator and put 2 to the third power in the calculator. Does it equal 8? Yes, it does, so that must mean we're correct. If we had messed up and we had put 2 to the 8th power equals 3, we would go in and put it in our calculator, 2 to the 8th power. We would see that it is not 3, so it must be wrong. Well, let's go over to example 2. Let's do our b. b is 4. X is 1 divided by 256. And y is negative 4. So we're going to do 4 to the negative 4th power equals 1 divided by 256. Go put that in your calculator. 4 to the negative 4th power. Did you get 1 divided by 256? If you did, you got it right. If not, it's incorrect. Okay, now let's go the other way. I'm giving you an exponential function and I want you to write it in logarithmic form. So let's do the same thing here. b is 15. Here we y is the exponent. And x is 3,375. So we're going to do log 15. X is next, so 3,375. Notice where I put that 15, I put it lower. It's a subscript. Make sure that that 15 is lower. Equals 3. So how are we going to read this? We're going to read it log base 15 of 3,375 equals 3. Well, let's go to number 4. Our base or our b is 4. Our y is 1/2. And our x is 2. So we're going to say log base 4 of 2 equals 1/2. Okay, let's go to example 5 and 6 we're going to solve. Notice here we do not know what y is. We're in logarithm form, so we want to switch it to exponential form. So my first step is to switch it to exponential form. So I have 27 to the y power equals 3. If you need to do your b, x, and y, go right ahead. Now we have this in exponential form. Remember from previous lessons, we want to make sure that our bases are the same. So we want to make our bases 3. So 3 to what power is 27? I think it's 3 to the third power. And I want to bring down the y and bring down the 3. So now my exponent and my bases are the same, so I want to set the exponents equal. Pretty easy to see that my exponent on the left is 3y. A little bit harder to see on the right. What is my exponent? What do I have right here? There's Nothing there, so remember it's understood to be 1. So I have a 1 there. So 3y equals 1, and now I'm going to solve for y. And I have y equals 1/3. I want to check this. How do we check it? We're going to store 1/3 for y and then put that in the calculator. See if our two sides are equal. Let's do that. So I'm going to store 1/3 for y. And then I'm going to do 27 to the 1/3, or I don't need that. 23rd to the y power. And it equals 3, so I got it correct. So I have a true statement. Okay, let's look at number 4. First thing I want to do is change it to exponential. So I have 4 to the y power equals 1 divided by 64. I want to make the basis the same. I'd like to have my basis as 4. So 4 to what power is 64? So let's go to our calculator. 4 times 4. And that's not 64. So times 4 again. That is 64. So how many 4s did it take? 3. So 4 to the 3rd power . Okay, but I don't want 64. I want 1 divided by 64. So if we remember, we make that exponent negative. So I have 4 to the negative 3rd power. So 4 to the negative 3rd power is 1 divided by 64. If you want to check it, go to your calculator and check it. Now the bases are the same. So now I just set the exponents equal. So I have y equals negative 3. And go check it. 4 to the negative 3rd power is 1 divided by 64. Okay, now let's evaluate. What do you notice in these evaluates? There's no equal sign, so let's put an equal sign and let's just put y. So let's switch it to exponential. 6 to the y power equals 4. We want to get the bases the same. So we want to make both bases 4. 4 to what power gives me 16? 2. So 4 squared. And then I'm going to bring down everything else. I have the basis the same, so I'm going to set the exponents equal to y. Remember, there's no exponent here, so it's understood to be 1. And now I'm going to solve for y, and I get 1/2. Go back and check that. 16 to the 1/2 power, does it equal 4? Example 7, change it to exponential. 3 to the y equals 1/9. I want to make the basis the same. So I need to say 3 to what power gives me 1/9? Well, I'm not quite sure. So let's do 3 to what power gives me 9. I am sure about that. 3 squared equals 9. Now how do I make it that fraction? Remember, we just make the exponent negative. So 3 to the negative 2nd power equals 1 divided by 9. Bases are the same. So I set the exponents equal. Go back and check. Okay, now we're going to graph. So first thing we need to do is graph log base 3 of x equals y. Well, I'm not quite sure how to do that. So I want to change this to exponential. 3 to the y power equals x. Well, let's put that in the calculator. Oh, that's right, we can't do that. Why? Because it's not y equals. So remember what I said earlier at the very beginning of the lesson, that logarithm is the inverse of exponential. So inverse, let's remember what inverse is. Inverse is when I switch the x's and the y's. So let's switch the x and the y. So I have 3 to the x power equals y. I can graph that, so let's go to our calculator and let's graph 3 to the x power. And now I want to put that graph on my piece of paper. First thing we got to do is remember there's an asymptote. So our asymptote is at y equals 0. So I'm going to draw my asymptote with the dotted line. Remember, we want to get ordered pairs. Where do we get our ordered pairs? We get them from the table. I'm going to get the ordered pairs 0, 1, 1, 3, and 2, 9. 0, 1, 1, 3, 2, 9. I'm going to write those here too. 0, 1, 1, 3, and 3, 9. Alright, so let's remember, logarithm is the inverse of exponential. I've graphed the exponential function now. Inverse means switch the x's and the y's. So what are my new order pairs? 1, 0, 3, 1, 9, 3. I'm going to graph these. Now, first thing I did when I was graphing exponential was to graph the asymptote, and it was y equals 0. If I switch the x's and the y's, it's x equals 0. So my asymptote is x equals 0. I have a vertical asymptote. I'm going to plot the 3 points 1, 0, 3, 1, 9, 3. And the blue graph is my logarithmic graph. Blue is the graph for log base 3 of x equals y. So now we're going to look at blue. I want to do my asymptote. My asymptote is x equals 0. My domain. If I draw my domain line here, do I have an important point? Yes, I do. It's that asymptote. It's at 0. Open circle because it doesn't touch the asymptote, and the graph only goes to the right. It does not go to the left. So my domain is between 0 and infinity. Or I could say x is greater than 0. My range. Notice that my graph goes down and up forever, so my range is all real numbers. Now let's do the end behavior. As x approaches, f of x approaches. So, over here on the left, we're going left and down. Down to negative infinity, left to 0, because that asymptote is stopping it. So I have, as x approaches 0, f of x approaches negative infinity. Now let's do the right hand side. On the right, we're going right and up. Right to infinity, up to infinity. So as x approaches infinity, f of x approaches infinity. All right, let's look at this graph. Log base 3 of x minus 5 equals y. Does this equation look similar to the last equation that we just graphed? Yes, it does. Only difference here is that minus 5. So if we remember what we've learned all year long, what does that minus 5 do to the parent graph? Let's go back to our last one. Blue is the parent as long as the base is 3. So what does the minus 5 do? If we remember, that's outside minus 5. So it's going down. So we have a vertical shift down 5 units. So if I move all my points down 5 units, I'm going to have my new graph. So I don't need to do all the switching that I did in the last one. My asymptote doesn't change because I'm just moving it down. 0, 1, that moves, 1, 0 moves down to 1, negative 5. 3, 1. 3, 1. That will move down to 3, negative 4. And 9, 3 will move to 9, negative 2. And now I got my new graph. So let's do the asymptote. Still x equals 0. Let's do my domain. Let's draw my domain line. Negative infinity. Infinity, remember the asymptote is the key point. I'm going to draw a open circle and the graph goes to the right, so my domain is between 0 and infinity, or I could say x is greater than 0. Range, we're going up and down forever, so range is all reals. In behavior, so we're going left and down to negative infinity, left to 0, because that graph cannot go past 0 because of the asymptote. So as x approaches 0, f of x approaches negative infinity. Go to the right here, we're going right and up, right to infinity, up to infinity. So as x approaches infinity, f of x approaches infinity. Okay, let's look at one more graph. What do we notice about this graph? We should notice that it looks very similar to the last two, except this time I have the minus 5 inside. So remember, that's a horizontal shift. We're going horizontal to the right. So I'm going to move my asymptote to the right 5 units. So my asymptote is x equals 5. Right, now I need to move all those points right 5. So let's go back to the parent. And we had 1, 0. We're going to move it 5 to the right. So now we're at 6, 0. We were at 3, 1. So now I'm going to go to 9, 1. And then I've run out of space. That other point was at 9, 3. Now it would be at 14, 3. So it's going to be out here somewhere. And there's my new graph. So let's look at the domain. Draw my domain line. Remember, the asymptote is the key point. That's at 5, open circle going to the right. So my domain is between 5 and infinity, or I could say x is greater than 5. Range, still going up and down forever, so we still have all reals for the range. In behavior, what are we doing here? We're going left and down. Left to what? 5, down to negative infinity. Here I'm going right and up to infinity, right to infinity. So let's write this. as x approaches 5, f of x approaches negative infinity. As x approaches infinity, f of x approaches infinity. Okay, I got a few problems for you to try. Here's some more for you to try. And then graph these 3 problems.